Hey YouTube, welcome back to my object-oriented TypeScript series. In this video, we'll go over inheritance. So in the very first video, we had an introduction with object-oriented programming, and I introduced you to a lot of concepts. And the developer, Bob, who was working on the object-oriented solution, this was his final solution, where we had a player class, and this player class is called a superclass because we have four other classes inheriting from the player superclass. So the player is called a superclass, and Mario, Luigi, Toad, and Peach are called subclasses. And the player class has the move method and play sound method. There should be two parentheses right here. The player class has those two methods defined. And whenever a subclass inherits from a superclass, its methods get inherited. So Mario, Luigi, and Toad move and play their voice recording normally, so they don't have to re-implement those methods. But because Peach has special behavior to the Peach class, we can override the method, right? So in this example, Peach was flying, and she also had a different type of voice file, WAV file, compared to the MP3 files. We can override players' methods by redeclaring the methods and having Peach specific behavior. The first benefit that we'll talk about when it comes to inheritance is removing code duplication. The second benefit is flexibility, which we'll go over in the next video with polymorphism. Going back to the first benefit with inheritance, which is removing code duplication. Code duplication is something that we always want to remove in our code bases because code duplication makes our code very error prone. For example, if we have code in 3 different places, or 4 different places like here, the move, play sound methods, what happens if we wanted to change the move behavior for all classes? We would have to update each and every class, which is very annoying. And more so, we could forget to update one specific method on one class, and then we would have a bug because one player would be moving differently than the other players. And we do this in programming everywhere, right? You do this with loops. You don't, let's go to our code editor. If you want to print, number from 1 to 10, you're not going to do console.log 1, 2, and so on, right? You're going to write a loop. You're going to write a for loop. You're going to go all the way to 10, and then you're going to print out I, right? This removes code duplication. And you also do this with functions. Let's say if you want to do this over and over again, you're not going to copy and paste this 5 times. You're just going to write a function, print nums, that does this, and then you can call print nums 5 times instead, right? This removes code duplication. We have function reuse. Now going back to the classes, inheritance is the same idea that we want to remove code duplication. We want to pull out and abstract all the common methods shared amongst the subclasses into the superclass, right? And then once we link the 4 player classes with the superclass, then they can inherit the superclass's methods. So in this video, I'm going to work with a new example. Instead of the Mario clone, let's pretend that we're going to create an animal simulation. So let's create an animal class. We're gonna have to need animals in our game. And let's ask the question, what does an animal know? Because what an animal knows is its state and hence its instance variables. It knows its hunger, which let's say is a rating out of 10, so it's gonna be a number. It knows its health. And let's say there's location. We have the x coordinate and the y coordinate. And then what is its behavior? Whoops, let's change that to y. What is the behavior? So an animal can eat, it can sleep, let's say it can move, and it can make a noise. And let's implement these methods for all animals. So basic, I'm eating, I'm sleeping, and for move, as you can guess, I'm moving, and for make noise. And now let's create, so now that we have animals, we can create subclasses, right? Our animal is the superclass, and we can now create subclasses of it. So let's say we want to create a dog and we want to create a cat. How do we do the link, right? We draw the arrow from the subclasses to the superclass. How do we link them? And we do this with the keyword extends. So we have class dog extends an animal, right? This is inheritance. A dog is inheriting everything from the animal. So the dog extends the animal, the cat extends an animal as well. So to show you that dog and cat are indeed inheriting everything, let's create a dog. New dog. And let us call dog, right? And we have the dot operator. We can already see that all of the IntelliSense, we have access to the animals, instance variables, and methods because the dog is inheriting all of them. So let's make some noise on the dog. Let's go into our terminal, and we get make noise. So the dog, we want to have specific behavior to the dog. We don't want this general make noise method. So what we do is override the make noise. And the way we override the methods is just by redeclaring them. And we can console.log bark. So let's compile. And let's run the JS. And we get bark, see? And for comparison, let's create a cat alongside the dog. And let's make a noise on the cat. And we'll see that the cat, because we didn't override anything, still inherits the regular make noise behavior. But the dog has specific behavior because it overrided it. So we have bark and make noise. We can also make these methods more complex. They don't have to be basic console.logs. Let's say this return to owner method, we want to print, let's say, its current position, right? We can access these instance variables because the dog has inherited these instance variables. And here, if we wanted to print out its position first before returning to owner, we can do that. So I want to print out I'm at this, and we have access to all of the superclasses, instance variables, and methods as well. So we can, let's say I'm at here, I'm at this dot chord x and this dot chord y. And now I'm returning to owner, right? Now here for the dog, we have to set x and y first. And from the previous video, you now know that doing something like this is not good because it breaks encapsulation. So instead, we'll create getters and setters. So for this example, we don't really need getters per se. All we really need to do is set them so that this method return to owner can access them. So we're just going to create set coordinate x. This is going to take an x, and this is going to be a number. And what this is going to do is set this dot chord x equal to x, and we'll do the same thing for y. Obviously, this entire class is not encapsulated, but for the specific example, we will encapsulate the variables, the instance variables. This is y, and chord y equals y. And of course, we have no logic to check if x and y are valid. So this is not different from having public variables, but for now, we'll just roll with this. But just know that this is not really encapsulated because we still have access to set them to whatever we want. So right here, we're going to remove this, and we're going to set dog dot set coordinate x to 10, and we'll do the same thing with y. And here is the first thing that you'll see is an error. Y is the dog. We have type errors. It says property chord x is private and only accessible within class animal. So when I first told you that the subclass inherits everything in instance variables and methods, I wasn't telling the entire truth. The superclass's private variables do not get inherited by subclasses. If it's private, we do not have access to it. So there's another keyword that TypeScript has, which is called protected. And what protected is the same thing as, it's similar to private, as in we cannot access these two variables outside of the animal class. But when we when we create subclasses and we inherit from the animal class, we can still access this outside the animal class. So I'm going to collapse this animal class right here. We can still access the two protected instance variables from the animal class from dog. So we have no more type errors. So that's also a new keyword that you will learn. And then let's run the JS. And of course, I forgot to call the method. So right here, let's call dog.return to owner. And great, we get the behavior that we're looking for. I'm at 10:10, and now I'm returning to owner. So this method, we can see that we can override methods with make noise. We can create new methods that don't exist on the superclass, and we can also access its superclass's instance variables with this. And we also got introduced to the protected keyword, which is similar to private, but allows subclasses to access its variables as well. So going back to why we use inheritance, the first reason that you're being introduced to right now in this video is removing code duplication, right? We can create many objects. We can create cats, we can create dogs, we can create wolves, right? And you can see here, let's say I wanted to create more animals, like wolf equals new wolf, right? All we have to do is create a wolf class that extends the animal, and we don't have to provide any extra code, right? Because all the code exists in the animal. So then I can create cats and wolves and dogs, but if I do need to have specific behavior, then I can override it by just redeclaring the methods. And another benefit of inheritance is that it allows us to model our code according to how we think in the real world, right? So two keywords, two terminologies that you'll hear around, that you'll hear when working with object-oriented programming is ISA and HASA, right? So we see that when a dog extends an animal, a dog is a animal, right? Because a dog is an animal. So whenever you have the extends keyword, the left-hand side is a right-hand side. And we also have the has a relationship. So an animal has hunger, it has health, it has an X coordinate and it has a Y coordinate. And a dog here, we don't have anything created here, but we can create new instance variables as well. We can, let's say a dog has an owner, right, which is a string. A dog has a owner. So ISA and HASA are two relationships that you need to be comfortable with when working with inheritance and object-oriented programming. And there's a specific test that you can use to make sure that your code makes sense and your hierarchy of classes and superclasses and subclasses. And that's called the ISA test. You can say out loud, is a dog an animal? A dog is an animal. If that makes sense, then your code is probably fine. But if it doesn't, let's say like a dog is let's say furniture. Let's say you're extending from some furniture class. That makes zero sense, right? So you're not modeling your code correct. So that's one test that you can use to make sure that your code and the way you're thinking about the real world is correct. The last thing that I want to introduce to you is, let's just delete all this code below here and we still have the animal class, is inheriting 2 levels down or multiple levels down, right? We don't have to stop at the first level. So let's say we had a canine class, right? So we have a class canine and extends an animal because canine is an animal. And we know all canines can bark, let's say, right? Or we know that, yeah, we know it barks. So we're going to override the make noise method. We're going to redeclare it. So console.log bark, bark, bark. But then we don't have to stop here. We can also extend the canine. So we can say dog extends canine, right? And what a dog has is, let's say, it has an owner, which is a string. And if I want to, let's say a dog has a method called return to owner, and this just prints out returning to, let's make template strings, returning to this dot owner. And here, that's the dog class. I'm going to collapse that. We can also have a wolf class, right? So you can see with this inheritance that we can keep it going. We can model hierarchies that appear in the natural world with inheritance, right? So the dog class will have its behavior. So let's say dog. And we can see it has all of the inherited behavior. It has its stuff declared in dog. It has the make noise method, and it has all of these methods and instance variables from the animal, right? Dog, right? Return to owner and owner were belonging to the dog class. Make noise, we could also write because it belongs to the canine, because a dog is a canine. And we could also get access to, let's say, eat, sleep, and move because the dog is an animal. So we also have access to eat, sleep, and move because since a dog is a canine, right? A dog extends a canine. So a dog is a canine. And a canine extends an animal. So a canine is an animal. Then we get that a dog is an animal too. It's a canine and it is an animal. So inheritance can flow through multiple classes, right? A canine is an animal and a dog is a canine. So a dog is a canine, but it's also an animal. So I forgot to talk about an important concept when it comes to inheritance that's similar to overriding methods, and that's extending method. So this should really come after the overriding example, but if I edited this example inside, in between there, it's not gonna make sense because then it's gonna like disappear because I built onto that example. But let's do this. It should be simple. So I just pasted the animal class, and this one is simple. It only has an x and y coordinate, and they are private, and we have two setters that don't really do anything to encapsulate because we have no logic, but that's just for the theoretical point that I'm trying to make. And we have two main methods. So these are just two setters, and we have two methods, make noise and move. Make noise is overridden by the dog. So if we create a dog, new dog, and we call dog.makeNoise, this will print out bark, 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 right? So we completely overrided the make noise method, right? This line will not be executed. Let's say we wanted to, instead of for the move behavior, we wanted to just build on top of the behavior of the move method that the animal class already provides. We don't want to completely override it or erase it. So we can access the animal's class with the keyword called super. So let's say we're creating the move method, and we first want to print out, let's say, getting up on all four paws, and then we'll print out the animal class's move method, which is just I'm moving from chord something something, right? And what we want to do is this behavior builds on top. It extends the animal's behavior. It extends the animal's move method. Here's the new stuff that we want to include, and this is the animal's behavior. So the way we access the superclasses class is just with the keyword super, because it's a super class. And what we can do is we can call super.move, right? And before that, so this is going to print out this. Whoops. This is going to print out this. And then when we want to print out this, we can just simply remove this and log this right here. So let us test this out. We're going to move, open our terminal, compile this, and then run it in JS. And we can see the first example, the first line, bark, 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 we are completely overriding the superclass's make noise method. But in the second, when we invoke the move method instead, we can see that we are extending the animal's move method, right? We first log our custom behavior that we want for the dog, getting up on all four paws. And then we call super.move. And of course here it's undefined because we forgot to set them. So let's do that. Let's do dog.set. Let's do dog.setChordX equals 54. I'm getting tired. And this one's 48. And this is y, right? So when we compile it, whoops, that's not gonna work. Compile it. And then let's run it with node. We can see that the move method correctly extends the behavior, right? So when you are dealing with subclasses and you need subclass specific behavior, you have two options. You can completely override, or you can simply extend and access these superclass with the super keyword. So yeah, that's it. I'll see you in the next video.